In the realm of space exploration, returning humans to the moon requires a rocket of truly monumental proportions. Over half a century ago, the iconic Saturn V fulfilled this role, propelling astronauts beyond Earth's orbit. Today, NASA's Space Launch System (SLS) stands as its spiritual successor, boasting even greater power and the unique distinction of being a rocket cannibal, a behemoth assembled from the remnants of its predecessors. The need for a new moon rocket. Since the conclusion of the Apollo program with Apollo 17 splashdown in 1972, human space exploration has been largely confined to low Earth orbit, reaching no further than about 650 kilometers from Earth's surface. While this distance allowed for valuable scientific research and technological development, it pales in comparison to the 386,000-kilometer journey required to reach the moon. For 3 decades, NASA's Space Shuttle served as the workhorse of American spaceflight, ferrying astronauts and cargo to and from low Earth orbit. The shuttle's missions ranged from conducting microgravity experiments to launching deep space probes and maintaining the Hubble Space Telescope. However, with the retirement of the shuttle fleet in 2011, NASA faced the challenge of developing a new vehicle capable of not only continuing missions to low Earth orbit, but also returning humans to the moon and beyond. The birth of the Space Launch System. In 2010, as the shuttle program neared its end, the U.S. government recognized the need for a replacement vehicle. While private companies were encouraged to develop their own space technologies, Congress also mandated NASA to create the Space Launch System. This mandate came with a unique stipulation. The SLS program was instructed to utilize pre-existing technologies wherever practical, including components from the retired space shuttles. This directive served multiple purposes. Cost efficiency. By repurposing existing technology, the program could potentially save on development costs. Reliability. Using proven components could enhance the overall reliability of the new system. Political considerations. Reusing shuttle parts would help maintain jobs in congressional districts associated with the space program. Designing a modular moon rocket. The SLS was conceived as more than just a shuttle replacement. It needed to be capable of sending humans back to the moon and potentially beyond. To meet these diverse mission requirements, engineers designed the SLS to be modular, with different configurations for various mission profiles. Lunar missions. A specific configuration optimized for sending humans to the moon. Deep space probes. Another setup designed for launching massive interplanetary spacecraft. Despite these variations, each SLS configuration shares a common core stage featuring 4 main engines derived from the Space Shuttle. This represents an upgrade from the shuttle, which used 3 main engines for its missions to low Earth orbit. The additional engine provides the extra thrust necessary for more ambitious deep space missions. Cannibalizing the shuttle. The SLS's design incorporates several key components from the Space Shuttle program. Main engines. The core stage of the SLS uses 4 RS-25 engines, the same type that powered the Space Shuttle. These engines have been adapted and upgraded for their new role in the SLS. Solid rocket boosters. Some SLS configurations employ enlarged versions of the solid rocket boosters used by the shuttle. Overall aesthetic. The SLS's paint scheme and general appearance evoke a fusion of the Space Shuttle and the Saturn V, creating a visual link between NASA's past and future. This approach of repurposing shuttle technology has led to the SLS being dubbed a rocket cannibal, consuming parts of its predecessor to fuel the next generation of space exploration. The Artemis program and SLS. The SLS serves as the cornerstone of NASA's Artemis program, an ambitious initiative aimed at returning humans to the moon. Named after the twin sister of Apollo in Greek mythology, Artemis represents a collaborative effort between NASA and a global network of space agencies. The program's goals include conducting new scientific research on the moon, prospecting for lunar resources, studying the feasibility of establishing a permanent lunar base. The Artemis program has set forth a series of missions to achieve these objectives. Artemis I, 2022, an uncrewed test flight that sent the Orion capsule around the moon and back to Earth. This mission marked the SLS's first flight and set a new record for the most powerful rocket ever launched. Artemis II, scheduled for 2024, the first crewed mission of the program, which will send astronauts on a lunar flyby without landing. Artemis III, Targeted for 2025, this mission aims to return human boots to the lunar surface for the first time since 1972. Progress and challenges. The development of the SLS has not been without its challenges. Initially slated to be mission-ready by 2017, the program faced numerous delays and cost overruns. It wasn't until 2022 that an SLS rocket finally took flight with the Artemis I mission. Despite these setbacks, progress continues. As of September 2023, engineers have successfully attached the 4 shuttle-derived engines to the core stage of the Artemis II SLS. Fabrication has begun on components for the Artemis III SLS. Controversy and competition. The SLS program has been a subject of controversy, primarily due to its enormous cost. Initial budget estimates of $6 billion had reportedly quadrupled by the time of the first launch. In September 2023, a government audit labeled the SLS an unaffordable means of achieving the Artemis mission goals. Several factors contribute to the SLS's high costs. Non-reusability. Unlike the Space Shuttle or emerging technologies from private companies, the SLS is not designed to be reused, requiring a new rocket for each mission. Development delays. The extended timeline for bringing the SLS to operational status has inflated costs. Political considerations. The mandate to use existing technologies and maintain jobs in certain congressional districts may have limited opportunities for cost-saving innovations. The SLS also faces competition from the private sector, most notably SpaceX's Starship rocket. Starship promises to be both more powerful and reusable, potentially offering a more cost-effective alternative for deep space missions. However, Starship's development has also faced challenges, with its first test flight in April 2023 ending in an explosion. Defenders of the SLS argue that its use of proven technology from the shuttle program makes it a more reliable option for critical missions like Artemis, where human lives are at stake. This reliability factor, combined with the investments already made in the program, has helped secure the SLS's near-term future. The future of SLS and deep space exploration. Looking beyond the initial Artemis missions, NASA envisions potential applications for the SLS in even more ambitious endeavors, establishing a permanent moon base, supporting crewed missions to Mars, launching large scientific payloads to the outer solar system. However, the long-term viability of the SLS will likely depend on its ability to demonstrate success in the Artemis program and potential reductions in per-launch costs. As private companies continue to develop their own heavy lift capabilities, NASA may need to reassess the role of SLS in its future exploration plans. Conclusion. The Space Launch System represents a bridge between NASA's storied past and its ambitious future. By repurposing technology from the Space Shuttle era, the SLS embodies both the agency's legacy and its drive to push the boundaries of human space exploration. As the most powerful operational rocket in the world, it stands poised to return humans to the moon and potentially open new frontiers in deep space exploration. While challenges remain, particularly in terms of cost and competition from the private sector, the SLS continues to progress towards its goal of launching crewed missions beyond low Earth orbit. Its success or failure may well shape the future of human space exploration for decades to come. As we look to the stars and dream of human footprints on distant worlds, the Space Launch System serves as a testament to human ingenuity and the enduring spirit of exploration. Whether it ultimately proves to be a stepping stone to greater things or a final hurrah for traditional government-led space programs, the SLS has already secured its place in the annals of spaceflight history.